Tonight, we are going to push this telescope to its absolute limit, to see just how far across the universe our eyes can travel. Starting close to home and leaping farther and farther with every step, we'll journey from the familiar to the edge of existence itself. Ready? Let's go. We begin with the moon, only 384,000 kilometers away. Its light reaching us in just 1.3 seconds. Easy. Now the rules. Every step we take will be 1,000 times farther than the last. So next up, Jupiter, 600 million miles away. Even though it's massive, tens of thousands of Earths could fit inside. Through our telescope, it still looks surprisingly small. That's distance for you. Now we leap outward into the icy darkness of the Oort cloud, where billions of frozen comets drift to light years from the sun. We can't see them directly, but sometimes one falls toward the inner solar system, a cosmic bullet traveling fast enough to wipe us all out. Chilling thought, isn't it? Another 1,000 times farther, and we hit the Orion Nebula, a colossal star factory. Our entire solar system would look like a speck inside this monstrous cloud. Here stars are born, burning through the dust. It is both breathtaking and terrifying. But we can't stop here. We're leaving the Milky Way, passing globular clusters, ancient spheres of stars, whose light began traveling as humans first walked the Earth 100,000 years away. Then, a giant step takes us millions of light years out. Look, the Andromeda Galaxy. A hazy smudge to the naked eye, but in truth, a swirling island of 1 trillion stars, 2.5 million light years away. Its sheer size dwarfs imagination. Further still, 30 million light years, we arrive at the Whirlpool Galaxy, locked in a cosmic collision with its neighbor. The light hitting our telescope left before primates first stood upright. Across empty space, 30 million years of travel, just so we could see it tonight. But we are not finished. At 300 million light-years, galaxies gather in enormous clusters, thousands packed together. Their light left long before the dinosaurs ever existed, stretched redder and redder as the universe expands. Proof we live inside an ever-growing cosmos. Now comes the real leap, quasar. For a long time mistaken as stars, these are in fact galaxy-sized engines, powered by supermassive black holes, brighter than 1 trillion suns. 8 billion light-years away, yet still visible thanks to their sheer power. And then, something extraordinary. A quasar splitting into 2 images. Gravitational lensing. A distant object light bent by something unimaginably massive between us and it, turning one quasar into 2. Einstein predicted it, and here it is, painted across our night sky. 12 billion light-years. At this distance, we can begin to glimpse the most remote galaxies, faint arcs of light frozen from the earliest moments of time. While their photons were traveling to us, the universe itself expanded, meaning these galaxies are now even farther away than 12 billion light-years. It is as close to the beginning as our telescope can possibly reach. And that, ladies and gentlemen's the edge. We began with the moon, a short 1-second leap, and ended at the dawn of creation, at the birth of space and time. So how far can we see with a telescope? Far enough to touch the very edge of the universe,